Okay, so shall we start?
Yeah.
Great. So this presentation would be in basically points. One is I'll showcase you what is voice to voice of customer and fundamentally how is it worked around in industry. And this is a very brilliant use case that most of the companies do, right? Now, let's say, for example, that you are an buyer, okay, regular buyer on Amazon, and you are a very loyal customer of Amazon. So whenever you want to buy, let's say, gadgets, or let's say you want to buy stationery or groceries, every time you go on Amazon. So you are a loyal customer of Amazon. Now, the problem that happens is you will not have the same kind of experience when you're buying different products on Amazon. Now, you might be very much happy when you buy a laptop because it's working well, but what if that Amazon pantry is not good, right? Or let's say, for example, the stationeries that you buy on Amazon are not good. So you become loyal customer of Amazon, but you have some negative opinion about certain products. Now, the question that comes is that imagine that you're working as a data scientist for Amazon itself. And while working for Amazon, they have given you a job to basically understand what your customers or Amazon's customers are talking about. Now, when somebody asks you this question, you try to figure first most important thing. What is the source of feedback that these customers give online, right? Once you know these are the source feedback sources, then you will try and find out which of these feedbacks are real, right? And which of these feedbacks are paid. So recently I came across a WhatsApp group where you just go online and buy a product of Amazon, and what these groups will do is basically pay you the money back. The product is also yours, and the only thing that you have to do is go online, go on Amazon's website, okay, or social media, and post good things about that particular product. Now, Amazon is not involved in this. Who is involved? The seller who is selling that particular product. Now, these kind of decisions are, or these kind of decisions of analyzing which is a real feedback and which is a fake feedback is difficult to assess, right? So point number one, we try to understand what are the different sources. Then we try to understand, okay, how many are real feedbacks and how many are fake feedbacks, right? Now we do lot other things, but before that, before I start understanding, so this is a business problem that was given to you. So what we will try to formulate is convert this problem statement into two parts. Part number one is to understand what would be the data sources from where you will get and what kind of analysis that you have to do. But when you want to reach that analysis part, fundamentally you will do something called as factor analysis, or maybe independent variable assessment. So what you will do here is try and understand, okay, what does the company actually need, right? So first and foremost thing is you have to separate the real and fake comments that come on Amazon, right? And on social media also you have to do the same thing. So step number one, find the sources. Step number two, segregate the real and fake feedbacks. Once you get the real feedbacks, what you need to do is try and understand for each and every product what are people trying to say. I'll give you an example. Let's say you go to Amazon and try to buy a Adidas shoe or a Nike shoe, right? Now the customers would, those who buy will come up online and say, hey, I did not get the right size. They said the size of the shoe is 9, but I received 9 which looks quite smaller, right? So it's not fitting well. Somebody will come and say that the shoes lace are not good. Somebody will say the quality of the shoe material is not good. Somebody will say it's really awesome. And somebody who wants to buy football shoes or badminton shoes, they will give their own specific comments. But when we are trying to analyze these comments, we need to fundamentally understand how do we showcase it to the end client. Now, you are working for Amazon, so your end client is also Amazon itself, right? But Amazon might go and tell these sellers that, hey, see, people are talking about this particular product. So you have two clients now. One is an end client and one is an immediate client. Immediate client is your Amazon, and end client is your actual seller, right? Now, Amazon also has come up with its own seller group, right? Online, and you can see so many shoes and all those. So even you can see their products like Amazon Basics and all those. So you need to be very precise and specific when we give the results to the end client, right? So always think with respect to end client and assess. Now, what, let's say, for example, you are trying to assess a shoe, right, for the end client. So for the shoe, people can talk about the design, the quality, the color. There might be a lot more things. So when you give an analysis back saying that, hey, 90% of your customers are talking about the design, and within design people are talking about this particular design, and people are also saying that if you to take this particular design or develop this design, we are ready to buy. Now these are all strategic impact based assessment that you have to do. So when you're giving an analysis, it's not the sentiment analysis or you are just searching keywords and giving nothing like that. So what you have to do is basically think of a bigger picture, what would be there. So let's start with today's session. So as everybody can see this particular screen, right? Can everyone see the screen? Right. So there are various voice of customers. So this slide is called voice of customer diagram. You can see various different sources that come. One is the online customer survey. So whenever you buy a product, you might well go ahead and give a link to the customer and say, hey, once you receive this particular product and use it for first 30 days, please give us some online comments. You can do that. Next thing is you can go ahead and basically give a net promoter score. So basically what happens in that survey is if you get the survey at the end of this, you will give a rating. Ranges from 0 to 10. So if you give 9 and 10 or 8, 9 and 10, you are called a promoter. Anything between 4 and 7 is called a neutral, and anything less than 4 is called a detractor. So net promoter score fundamentally means how well you like the end product, right? Next is live chatbots. So basically, let's say Amazon has a chatbot and then you go ahead and give feedbacks. So on the live chatbot, all that feedback will be recorded as textual format, right? Next is email service. So you send an email to Amazon or you send an email to seller saying that, hey, and keeping Amazon in loop. You say that, hey, this product is not good. These are the this is my feedback. These are the pros. These are the cons, right? Offline survey. So let's say, for example, this is not related to Amazon. So whenever you go to an offline store, maybe an Adidas store or a Nike store or maybe a Reebok store, there you will find survey cards. So you need to fill that up, write your name and stuff, and you have to write down how was it, right? So this is more related to the staff behavior in the offline store, right? If the staff is rude, you write down the statements and all. Next input data set or source is the customer interviews. So randomly what these people do is these people call up the customers and say, hey, did you like the product? This is the product that you have got. Did you like the design of it? So they might ask you very pinpointed questions which will basically help them do the analysis. Next is social media and online reviews. Now social media is very broad and a lot of people write into consumer complaints, people write into different locations, right? Now where did machine learning, data science and all those come? So initially what used to happen is all of these used to go in a database, and then what people used to do is manually read through the comments and get the themes of that. Like this particular customer talked about design and he was unhappy and all those, right? All of those these people used to manually go through.
Now, because of text analytics and natural language processing, people started understanding that, okay, we can automate this process. Okay, so before I start with natural language processing, let me just explain you. Natural language is the language that we speak, right? Machine language is this language that machine speaks, like 0, 1, right? All those things, ASCII format and all those. Now the problem here is whenever you speak to the system should understand it in a proper language, right? So there is a processing technique, or maybe at a higher level natural language techniques, which basically help the system to understand basis what we give as an input. Like, say for example, if I write that I do not like Reebok shoes because it does not have a grip, right? Now the system should understand that, okay, what are the important parts within this. He's talking about Reebok shoes, does not like, what he does not like, the grip he does not like. Now, extracting all of these, you need to have a linguistic understanding or a natural language understanding, correct? Now, NLP fundamentally consists of two things. One is natural language understanding, that is, you understand what the context is. Next is natural language generation. So there are a lot of chatbots in the market. What they do is they will generate textual output from. There is no human on the back end. So from the front end, what will happen is you ask a question saying that, okay, can you tell me what is my insurance premium that is due on this date? And the chatbot will automatically give an answer. Now, when this question comes, right? When this question comes, what happens is your sentence is converted into the right entities. Like the question I asked, right? Premium, due date, and what is my ID number. Now, basis that it will go on the back end, go to the database and fetch the right answer. But here the problem is when you want to fetch it on the back end, the system automatically does not know, right? So you need to create a mechanism where it understands that, okay, in the database, in a particular table, this is the column where I have to go. Now, doing that is basically called natural language to query, or it also called as natural language querying, right? So natural language understanding, natural language querying, natural language generation. So if the system is able to write back the answer in a proper grammatical format and act as a human from the backend, then it is called natural language generation. So there are three things. One is natural language understanding, second is natural language querying, and third is natural language generation. And basically at an umbrella level, it is natural language processing. So this ends the sources, data sources. Okay, next, most important thing. Any successful voice of analytics or voice of customer kind of a program successfully contains three things. One is you understand the voice of the customer. As I said that did not like the Reebok shoes because the grip was not good. There might be 1 lakh more customers who will come up and say these kind of statements. Some people might not like the lace, some people might not like the design, some people might like the design, right? So voice of customers, once you define it, the next thing that is most important is it influences the marketing. Now, when you want to market certain product, you will obviously talk about features of the product, right? If the customers are unhappy about the features of the product, so step number one is all the customers, you take the voice of the customer, understand what particular designs are not, I mean, these customers are not happy about them. And then what you can do is go ahead and try and understand how do you change the marketing strategy. Next, most important thing, if let's say the maximum number of feedbacks are coming from social media, then what you can do is you can also try and increase the marketing budget of social media. You can put more number of ads. Now, because a lot of feedbacks are coming from one location, we can also put money there so that we have an ad, right? So there are two things that happens in marketing. One is basis what the customers are saying, you will change the product design or you will incorporate changes that the customers want. and then portray that into your marketing banner or your website, if you're putting the details on the website and all those, right? And then you will also put the money into those set of sources or channels. So all the sources that I told, right? One is your online survey, right? Like that, you have got social media. If social media maximum number of comments are coming, then what you can do, you can go ahead and put more money there. So this is a successful VOC program. So voice of the customer influences the marketing then changes back, and more number of customers are fed into the system. Next, this is an end-to-end process of a VOC. Number one, you collect data from various sources. Number one is unstructured data. A lot of people write chats, a lot of people put logs and all those things, right? Unstructured. Structured data, you have given a survey to, like, let's say for example 1 lakh users, and all of these 1 lakh users have filled up the form. Now obviously when somebody fills up the form, there would be a backend table where the data gets stored, right, in a structured format. Now the service would contain a question which will have answer yes, no. It will have multiple question, multiple multiple questions, multiple answer questions. And you will also have, let's say for example, social media data. Social media will have a lot of different kind of uh, what you call uh, points that people mention in different locations, which capturing those is unstructured format, right? Any textual context or text or a paragraph that people write is considered unstructured. If somebody gives an answer to a question and it's like a multiple choice kind of a question, then that particular thing is fundamentally called as structured data, which is fed into the table. Once we extract all that data, then what we do, we try to do few things. One is text analytics. Text analytics means, as I said, right, if I write a statement saying that, hey, I don't like Reebok shoes because it does not have grip, correct? Now here, the word Reebok, the brand name, shoe, what is the product, right? What does the customer like, what does the customer do not like, all those things. When you want to extract as entities, it's called text analytics, right? Next is speech analysis. Speech analysis means, let's say I call up a customer care center, and then I'm talking to the customer care agent and I'm saying that I don't like this particular shoes because of this, that, and all. Entire voice gets recorded and on the fly gets converted into text, and the analysis is done. So at the end of the day, imagine like this: you do all of these analysis, go back to your Amazon chief and say, hey, I did analysis on 1 lakh products, and for each and every product I have got approximately 1 lakh comments online, or 1,000 comments, or whatever number of comments. And for each of the product, I am able to tell you that people don't like this because of these features, people like this because of these features. Now for your chief, now it becomes very easy that what product have maximum number of negative points and what products have maximum number of positive points. And then he will go back to the particular seller and say, hey, people are talking about this, try to improve. If you do not improve, then we might have to close there because the sales are going down. So these kind of analysis can be done. Next is sentiment scoring. Now initially sentiment used to be positive, negative, neutral. Now you are getting emotion analysis as well, right? Next is research scientists. So research scientists, the reason why we have written research scientists and consultants is there might be certain set of people, like subject matter expert into linguistics, who will be able to understand it more deeper, try and define, okay, is there any relationship between this word to that word, like that, right? And similarly they can go ahead and showcase you how exactly we can improve the model and all those. Next again comes collect. So collect, analyze, collect, analyze. So now this collect is not the data source collection. This collect is basically to convert your entire analysis into reports, dashboards, alerts, and recommendations. So you can generate a report and showcase it to the end clients and hey, see, these are the things that your customers are saying. Then what you can do is you can go ahead and create dashboards. Now dashboard basically would be showcasing, okay, these are the top 10 products that are being sold. This was the first day when the product was sold. Customers are talking about this product like this, right? The entire charts and everything you can show. Next is alert. If let's say your negativity percentage for a particular product is going more than 70%, then you can automatically put a trigger saying that okay, if it goes more than 70%, please come and please send an email to the end client as well as to the team leader who is there in the Amazon group, right? Next is recommendations. Now because you have a subject matter expert who is into linguistics and you have data scientist and you take one more expert who is into product design, right? Or you take help of your end client and you can generate recommendations. So if you do this and if you do this, then the number of products that are being sold will increase, right? Next is analyze. Now once you so first analysis was converting the raw data into some meaningful outcome. Last analyze is once you know that these are the recommendations, you can go ahead and try and understand, okay, what are the design changes I should go and do? What need to be done in a competitive fashion? Because what happens is when Amazon sells the product, it will sell products from Adidas, Nike, Reebok, Puma, everywhere. And it can tell you what fundamentally people are talking about for other products as well, right? And basis that understanding, they can give showcase and competitive edge for you, right? Similarly, they can do a benchmarking saying that okay, you are the third level within the list of all the different shoes that are there in the market, right? Next is KPI development, key performance indicators. So these key performance indicators help you to assess your goal. What is your goal? Is your goal to increase the revenue? Is the goal to increase sales, right? Is the goal to spread awareness? Basis your goal, the KPIs are a list of variables, okay, that will fundamentally help you to make an impact on these goals, correct? So that kind of, then change management, as I said, the design changes you can do, let's say for example, total revamp of your product and all those things, right? Next is basically, so this is the entire end-to-end VOC process that happens, right? And there are a lot of places within this that you require natural language processing. Let's go ahead. Fundamentally, a VOC diagram contains three things: listen, analyze, act. First is listen, second is analyze, and third is act, right? So listen to your customers, analyze what they are trying to say, take subsequent recommendations and actions. Voice of customers fundamentally can be assessed in four different ways. I mean, the data that you get is can be given in four different ways. One is text. I'm talking about the input data, right? One can be text. Second is call recordings. Third is online review videos. Now, let's say I put an ad of Reebok, or I put an ad of Dell, or I put an ad of, let's say, Samsung, right? For a particular product. How many people are viewing? At what point they are stopping, right? All of those can be assessed, right? And if you see recently there is a company, I will not name the firm. What they have done is it's basically a firm, something like Go right? But not Go I'm talking about. So what this firm has done is you come online to their website, and then as a customer you come online, and they are going to showcase you 10 to 20 different videos of different location, beaches, forts. They will showcase hill stations and all those, and they will capture your facial expression when each and every video is played, and on which frame of that particular video you are becoming happy, and in which frame you are neutral, and in which frame you are not happy at all, right? And basis that, at the end of all of these videos, it will showcase you It will first ask you a lot of things, right? What is your salary, and then how much you're ready to pay, and all those things. The basis that it will create a tailor made itinerary for you, all of you, right, who basically go online for an individual customer basically, and then it will showcase you only that part, only those cases where you were happy, right? Similarly, images. So all of these things come as an input when you talk about voice of customer. Now this is very important to understand. Somebody wrote, I want the pizza that I ordered. Now the next sentence is, I am not going to pay a lot for this pizza. Now what the system caught, and what do we need for analysis, right? Now some of the customers will write, I want the pizza to be ordered. Somebody will write, I want my pizza when you said it would be here, right? Next, somebody will say, I want my delivery person to be friendly, right? But what does the VOC system want? It wants pizza delivery person is polite, right? Pizza delivered on time as promised to the customer. Now this is the need, right? So your timeliness, your complaints, your pricing, your accuracy, all are very much important when you assess that. Now converting a standard verbatim, like I want my pizza when you said it would be here, to pizza delivered on time, right, needs to be very much, assessed. So somebody writes like this, then next time what happens is, if you know or identify that particular customer, you will basically go ahead and give the pizza within the time, and then the customer will come up and say pizza delivered on time as promised to the customer. Next, what is the difference between voice of business and voice of customer? Let's see this first. Repeat customer calls before resolving the complaint. Now there might be so many set of customers, before the complaint is resolved they will call 10 times, right? Say for example, I have a network issue with Vodafone, I'll call 10 times to the customer care. Next is, direct contact centers don't have customer complaint details. So I call up Vodafone and say I have problem, I spoke to the concerned agent 10 times, but I went to the offline center, right, Vodafone care center, manually I went there, and once I reached it, I started speaking to that particular person, and he does not have an idea that I have called call center 10 times, right? Next is complaints raised under wrong headers. Now my complaint was related to network, but because of the agent's issue, what has happened is he has written within the value added services. Next is, customers are not able to discuss the resolution. That means the agents are not able to spend more time, right? So if you see the top one, it says, I want the call to be attended within 1 minute of ringing, right? This is a very adamant customer. Next is, I want any complaint to be resolved in less than 2 days. He wants everything to be done in 2 days. I want the company to adhere to the resolution time promise. If the company says, okay, resolution time is, let's say, 2 days, then they have to do it in 2 days, right? Basis voice of customer. So business is more related to the operations of the business, and voice of the customer is, if you see, right, customer says takes too long to resolve a complaint. Turnaround time to solve a complaint is not heard. Matlab, fundamentally what this guy is going to do is going to ask the customer care person to solve the problem in 2 days. The customer says, yes, I can solve the problem in 2 days. But even the third day has come and not able to solve the problem. Next is, no consistency in the information shared. Now, they have not written things properly, which showcases that I am talking about my network related issue, right? Next is, complaints are resolved without concern. That means, let's say there is a hardware related issue, okay, for your set-top box. Now, without telling you, these people come to your house and try to solve the problem and go back. Now, without your concern, coming to your house, solving it, right, going on the terrace, solving the dish related issue, and then coming back is wrong, right? All of those are very much important. So if you see, The voice of business is fundamentally basis how your business is running, how your employees are working, and all those, right? And how many calls are coming to your call center and all those things. Voice of customer is very customer centered. So for individual customer, the problem might be different. Next, what are the feedback methods? Direct, indirect, inferred. Direct means you can give feedback through SMS, direct phone calls, or you can do some market research and put it on consumer complaints, right? Or let's say, for example, that these people will do some market research and try and find out, okay, now because my competitor is doing this, I think I might get negative feedback because of this, right? Next is indirect. Indirect means a website review, social media reviews, people write in forums, right? There's a good website called consumercomplaint.in, right? An Indian website. You go online and put all of the details that you do not like this washing machine of Samsung and all those. Next is inferred. Web clickstream data means if you, let's say, for example, that you put some details on your website, no one is going and watching your video, right? Or let's say if they go and watch your video, then they are coming out. What they are trying to do is basically they just click on the video, go there, and within 3-4 seconds they are coming out. Purchase history. They are going to your add to cart page. They have added to the cart, but they are not buying it, right? That means you go to Amazon, you try to buy a particular product, you go to Amazon, buy the product, end up going to the last page where you are trying to buy the product, and then you drop off, right? Next is transactional data. How many of them are actually buying your product? How many of them are actually giving surveys? How many of them are actually giving negative feedback, right? All of those comes from inferred way. Now, this is entirely with respect to the VOC that I was explaining about. Any questions on this? So I'll give you 2-3 minutes. So you can ask certain set of questions if you want. Like one of the question that I have is, where is machine learning in this? Anyone has that question? Okay, so fundamentally what happens is when you talk about a textual context, if I write a word, right, or a sentence basically, sorry. So if I write a sentence saying that I do not like Adidas shirt uh, because of the cloth quality, right? Something like that. Now, in this, the system has to understand without you giving keywords that what of this particular sentence is most important. Is the cloth important? Is the brand name important? Is the negative sentiment? So I do not like, right? So word do not like. Now, all of these things cannot be directly, keyword searched and automated. What you might have to do is you have to take a data set, huge data set that contains, let's say, 1 lakh sentences, and for each sentence it should say, it should have one or two more columns which says these are the entities and these are the intents. So intent was like, okay, what was entity? Cloth, Adidas, t-shirt. And for whom it is directed? Directed for a particular person, right? So what is most important is extraction of these entities and intents. Now in NLP, there are few packages called GenSim, GenSim, okay, and Spacey. So I'm writing that on the chat. So what these packages fundamentally do is help you to get something called as named entity recognition. So what this named entity recognition will do is basically try and understand what are the intents and what are the entities of your particular problem that you are trying to solve, right? So when you want to automate it, you cannot just text search and automate. you have to use a machine learning method, maybe a naive bias or a logistic regression, to predict that okay, this sentence is fundamentally talking about this, right? And sometimes what happens is, if you're trying to do sentiment analysis, you have to manually find out the sentiment, read the sentence and get the sentiment. Now there are various methods of classification algorithms. So we have seen few classification algorithms, right? So there are so many classification algorithms which can help us get the right class. So when you have a data set which says uh, positive and negative, or positive, negative, neutral, system should be able to understand that, right? So I will now give you a 10-minute break, right? And we will come back. And meanwhile, I would like you to go through few points. Okay, so the link that I'm sending you, I want you to view it, right? It's a YouTube video. Click on that and view it for next 15 minutes, 10-15 minutes. Copy that, paste it, view it, and I'll come back at 9 o'clock. And this video is fundamentally for all of them who want to join data science as their data science profession or data science domain as data scientists. So for all of them, how do you go about doing all of that is explained in this 15-minute video. Please go through this. Right. So this presentation would be in basically 2 points. Fine. Section from the back end. Very next. This is an end-to-end process of progress. Number one, you collect. Correct. So most important thing fundamentally is to come up to get more number of use cases, right? Test cases that you have to solve. Second is you need to grow interest in solving various problems, right? Next most important thing is you to develop your LinkedIn profile. See, everybody right now want to get into data science. You take any engineering background, sciences, mathematics, everyone wants to get into data science. Now, if you want to cut through this competition, then you need to follow these steps, right? Create a broader view. Don't get confined to one, right? Don't think that, okay, if I do deep learning, that means I am great. Nothing like that. So nobody is going to do research in deep learning and stuff. You just have to implement it, right? Or let's say, for example, if you are trying to solve very cutting edge, people are going to take you. It's not like that. Until unless, okay, you have built something totally new and there is a use of that in the market right now, then it is fine, right? But even if you do image analytics or complex speech analytics, rather than confining one, you should know all of them. So I'm not saying you have to become jack of all and master of none. You need to be master of one, but it's okay if you're being jack of all, right? So that is the most important point. You have to solve more number of problems, right? Now let's try and get into the other aspect. I will just share my screen. Okay, can you all see my screen right now? Okay, great. Okay, so what we are going to discuss today is more related to the voice of customer, right? So I have a project, right? The link of that particular data set, I will share it with you now, right? Now, okay, let me do one thing. Let me make you read the problem statement clearly. Let's see if I have the problem statement. Okay, so what I want you to do is read from this point till this point and just write down done once you complete it. Read from this point till this point. And once you read it, what you need to do is in one line, tell me what is the context of this problem.
Done? Okay, in one liner, tell me what does the client want from us? If this kind of problem comes to you, what do you think is a one line point which states the problem statement? Once you have completed, please write down the one line statement in the chat. What is the problem statement? Good, Rosina. Others? Is the system talking about what are your customers saying about broad set of products that you are trying to sell? Good, Aditya. Anyone else? So even if you go to corporate, right, you will get these kind of use cases only. So you will basically, if let's say, for example, you're working for company XYZ and your client is, let's say, for example, Vodafone, right? So they will come to and say that, okay, can you tell me or assess the feedback given by various customers, and can you segregate that into various constituent parts? Like say, for example, network related queries. Second would be, let's say, billing related queries. Third would be value added services, like that, right? So let's try and understand how can we solve this particular problem. Shall we start? Okay, can you see my Jupyter notebook screen? Yeah. Okay, so what we are trying to do here is we have imported so many packages. Everyone knows, right? Pandas, NumPy, datetime is for date and time. Matplotlib, word cloud, Seaborn are for visualization, right? sklearn, all of them is for creating the classification algorithms. Okay, I will zoom it a bit. Now clear? Is it clear now? Okay, next is we are trying to read the data. So if you see, if you've seen that text I had showed, right? You have review text, you have rating, you have class name, and you have age. So we have basically got only these, right? And once we do df head, right? df1 head, fundamentally you will get, so this anyhow will be removed, right? You will have clothing ID, you have all of this data, correct? Now the df or this df will contain only this. So if you see, if I run this, okay, so it is going to take some time because it's downloading it from the internet, right? So fundamentally what happens is when you write something like this, it fetches only those columns that are mentioned here. Okay, like this: review text, rating, class name. So it's talking about pants, dresses, all of these, and then what is the age, right? Next is, so all of these records that we are seeing here is one person entering the feedback, right? Next, what we are trying to do is trying to assess what are the various words in each of the sentence and what is the frequency of the word. So if you see here, right, loves this dress, it's so pretty. So am, and so there is a big sentence, okay, here. It got cut because of this thing, but it is going to get, okay, love how many times, this how many times, dress how many times, it's how many times, so how many times, pretty how many times. It is going to get all of that, right? So if you see the code clearly, it converts these blanks, right, into null. Count vectorizer is fundamentally used to count the number of words, okay, within that. Now this is a blank, so there is something called as build analyzer. So what this build analyzer tells is it converts that into word constraint value, word and constraint value, right? Next is word counts. This will give you this output like this, right? And if you see word count, this is the column that gets created and it's run on this, right? Any questions up till here? Coding we can take off later, but any logical question that you have here? Okay, let me move forward. Right. Okay. So can you read this entirely? It's very self-explanatory. I want you to read this. So basically what we are trying to do is for particular class names, what are the most important words that people are speaking about? And later on, we will also try and find out what is the sentiment. Please let me know once you're done. Done, all of you? Okay, so to make it more confined, right, as the fundamental point or the use case was to try and help the customer, so or the client of us who is selling this woman apparel, right, is to go ahead and tell, okay, what customers are talking about for certain set of types of dresses, right? So if you see this class name, this is the type of the product. Dresses, pants, all of these are type of the product. So now if, let's say for example, you go back and say, okay, for dresses, people are talking about this. Their sentiment is this. So it is more important, right? So what we have done is we have selected certain words which tell you the what you call emotion of the person. Like somebody says awesome, great, magnification, glad, satisfied, lucky, shocking, terrible, disappointed. So people have taken these kind of words. Either you can take these kind of words or you can make an entire set of word clouds. So here what we are trying to do is basically getting the count of each and every word in these set of sentences. So if you see, if you go ahead and see what happens is, okay, let me just explain this part. Okay, so if you take this data frame, we have created a copy called DFWC, word cloud, and for word in word. So it will take first word as awesome, right? And it is going to take the selected count. So selected count, if you see what happens is you are passing, uh, okay, so what happens, you have a dictionary, you are returning the, okay, so what happens here is fundamentally it will give you the word counts of each of the word occurrence in that particular data frame. So the original data frame, right? And what we have done here is we have just tried to convert that into a word cloud. So if you see the selected words, the size of the word that you're seeing here means more frequency. So people are talking about this word as, I mean, the apparels, and the word that they tell maximum, I mean, speak maximum is love. Somebody writes super, great, disappointed. So if you see at an overall level, people are more happy than sorrow, right? Now, what class names people are talking about? Knits, then sweaters, then dresses, pants, and all those. This is the overall word cloud. So if you see here, people are talking about love, shirt, top, dress, skirt, fabric, look, sweater, really, perfect, color, right? These are the top words that people are talking about. Next that you see here is we are trying to create a sentiment analyzer. So from the data set you have seen that people are talking about rating. So what we are trying to do is any rating greater than 4, that means 4 and 5, we are saying good, and anything less than 4, we are saying bad. Okay, so we created a data set called positive and negative. So 4 or higher, we are saying positive, then 2 or lower we are saying negative, right? So what we have done here is we have created only two, either positive or negative. Less than 4 negative, greater than 4 or equal to 4 is positive. So if you see here, true and false have come. Now basis this, I think most of you have attended my classification session, right, where we talked about stratified sampling, train test split, and all those. So here what we are trying to do is we are trying to do the same train test split. Training is 80%, testing is 20%, right? And you remember we have done the vectorization before. So vectorization will convert these words, right? Unique set of words, and put that. So let's say for example, in a particular statement, there is a word awesome, right? And the second statement, word awesome is not there. So for the word first statement, the awesome value is 1. But for the second statement, the word awesome value is 0. That is how this training data set is going to be created. So the training data set will not contain sentences. It will just have all the set of words. If the word is present in that particular sentence, then 1, else 0, right? And Y train is what? Your this column, right? So Y is your target, and it is converted into Y train, Y test, X train, X test. Okay, so can you tell me, see if I ask a question, is X set of independent variables or dependent variables? What is your answer? Okay, what is y here? What is y? Okay, wait, good, dependent. But what is the variable name? Correct, sentiment, right? Okay, is this a binary class problem or multi-class problem? Why? Because true and false, there are only two outcomes. Okay, so what we have done is we have implemented few algorithms. One is logistic, naive Bayes, and SVM and neural network. So we have implemented logistic, naive Bayes, SVM, and neural network. Okay, so the reason that we have taken this is because the proportions of yes and no is approximately 40% and yes is approximately 60%. That's a ballpark number, right? And in a binary classification problem, these are the best set of algorithms that are available. One is logistic regression, naive Bayes, support vector machine, and neural networks. So because these work well, we have selected these. It's not that we are running all of the algorithms and then saying that this is the best. For binary classification problem and not a very high bias data set, these algorithms are one of the best algorithms, right? So let me just copy and paste it in your chat, right? Okay, so once we start running this algorithm, we have calculated the elapsed time. So if you see, approximately 37 seconds goes for SVM, 13 for neural network, very less for naive Bayes, also very less for logistic regression. So this is the entire time taken for each of the algorithm. So that you see, first is logistic, naive Bayes, support vector machine, and neural network. MLP is called multi-layer perceptron, right? Once we do that, what we are trying to do is what is the output that we get of most of the algorithms. So original is this, and what did we predict, right? So we are just adding it to the data frame. So if you see, this is the serial number or basically the index number, this is the text, this is the rating, this is the class, age of the person, word count, what was the actual sentiment, this is the real data set, the real output, and this is the predicted output. So if you see, all are coming correct. Then we try and assess AUC. So I will explain you what this is. Okay, so everyone, previously we had done whatever confusion matrix, right? So everyone knows what is false positive, true positive, correct? So always your curve or the line or basically the curve basically here should be nearer to the true positive, right? So if you say that this is the curve, ROC is area under the curve. So if you consider this entire box as one, then if you write 0.95, that means 95% of the curve it has captured. So if the area is more, then the algorithm is better, right? So if you see here 0.95, 0.95 means this entire area you're saying. So this box is one and this is covering 95% of the box. Did you all understand? Any question on this? ROC is called receiver operator characteristics, right? So basically it tells you how exactly your algorithm is working. Any questions on this, please ask. Okay, so there is a concept in machine learning called receiver operator characteristics or receiver operating characteristics, right? what happens in this is most important within the confusion matrix are two. One is true positive and second is false positive, right? False positive means you consider that the outcome is positive, but it came negative, right? That is false positive. And true positive is you said that this thing is right and it's going to come and it has come, right? That is true positive. So your false positives should be always less and your true positives should always be high. So this receiver operating characteristics is basically a diagram or an image or a graph, right? Or basically an XY graph where X is your false positive and Y is your true positive. If your true positive is high, your area under, so your curve is drawn, right? So imagine, let me just copy this. I will explain you much better. And let me put paint. Do let me know if you are able to see the paint. Are you able to see the paint? Okay, let me just. Now, are you able to see? Yeah. So let me explain you this very well. Imagine that you have a graph like this. This is your false positive and this is your true positive, right? What happens is this entire diagram that you're seeing right now is called ROC, receiver operating characteristics. Okay. So what happens is if you're at this particular point you start running the algorithm, basically what happens is tries to calculate your true positiveness and false positiveness. If you get a graph like this, right, and basically what happens, it creates a bounding box. This entire bounding box is basically noted as 1, area is 1, right, for this entire box. Now what the system does is when it's time to run the algorithm, basically it starts printing this particular curve, right? Now anything within this particular curve in the box is called area under the curve, AUC. Okay, now a question for you. What is the full form of ROC and what is the full form of AUC? Write down fast. Fast, fast, write down. Correct. Right? Everybody understood what is AUC? And if AUC is nearer from 0.8 to 0.95, it is best. The algorithm is good. But here one more important thing you have to see is it should not overfit, right? So if you see this algorithm, right, it is coming slightly down. This and this are all similar, right? Everyone understood what is AUC, ROC, and how do you read this graph? Any questions, please ask. Any questions? Okay, great. So can you tell me from this graph, which of the algorithms look better or basically best? I'll tell you how to read this, right? So by the system, right, logistic regression naive bias are more interpretable. That means if you go back to the client and if you want to explain them, it is more easier because logistic regression will basically give you the coefficient values and naive Bayes will basically help you to get the rules, right? So these two are the best algorithms that can help you explain to the end client, right? Because they have certain features which can make your results more appreciable, right? Appreciable. Now, if you see this, the curve is more smoother. Here, if you see there is a dip. Here, if you see there is a dip, right? For any data scientist, if the curve is more smoother, it is better, right? And if there is a dip, it's not much. The fundamental reason is that if it is more smoother, that means even for any kind of data set that comes in future, it will work well. But here, if this kind of data set comes, wherever this dip has happened, then the system might fail. Understood? All of you? Correct. So Shubho, the area is same, right? But if you actually see to a four decimal number, like 0.95 something, right? Then your naive Bayes and logistic regression slightly must be different, right? So fundamentally, how what is the decimal point till which you are taking, that is very important, right? But best way to assess is even if the area under curve is like 0.01 less, best thing is to take a smoother curve, right? And next is the confusion matrix. Let's not go very deep into it. And now if you see, this is the end conclusion. I want you to read the end conclusion. Correct, Tushar. Okay, so here I'll end the session today, right? And I will pass on to you this entire sheet, right? Entire Jupyter notebook, okay, to BI, and BI will forward it to you. This gives you a very detailed understanding of everything that we have studied till date, from studying the basic Python to statistics probability, hypothesis testing, to clustering, to classification, right, to this problem statement. Everything is there within one single notebook file. Okay, exploratory data analysis, we did feature engineering, right? So not exhaustively. So we are not saying that we are doing exhaustively. Yeah, Abhishek. So this would be the last lecture. If any other lectures are required or you need some any other explanation on any other subject, then we can have an additional session for that. But this document, this Jupyter notebook, is the end-to-end implementation of a project in NLP using all of those that we have studied from day one, right? So you can go through this, and maybe if you all want, we can have one more session where we can discuss about various projects, any questions you have, right? Any other understanding you require, and all those. I'm happy to help. So we can go ahead and do that. But what I wanted to do is basically go through this entire Jupyter notebook and then come back with a proper analysis of all of these, right? And I will share a small presentation with you, right? A template with you, right? So a template wherein you have to fill it. So the next session, if you all want, we will have it after a week, right? After a week, maybe next Saturday or something like that. We will spare 2 hours and we will give you, we will put the ball in your court and you can ask whatever questions you want and whatever analysis you have done and all those. And I'll be happy to answer all of them. I mean, it can be related to job, it can be related to use cases, it can be related to core data science and all those. You all think of it, right? And tell me a time, not in the weekdays, right? Because weekdays I am busy with my office work. So weekends, Saturday or Sunday, we can keep a 2 hour session. You can take the entire week, write down all the points or all the questions that you have, but please solve this problem statement that I am giving you, right? End to end, and then those 2 hours you will fundamentally go ahead and I'll try to answer all of your questions within that, right? And you have to basically go through all the different uh, you know video links that I have created. So I will give you my channel related details, right? So you can just go through that, go through every video. There are different kind of use cases that I have showcased. One is insurance analytics, how to solve business problems, what are the various computer vision use cases, right? Some basics of measure of central tendency, right? And basics of machine learning and stuff. So if you want to go through, I've just sent a link on your chat. If you can bookmark that and then go ahead and view all of those videos, right? And basis that, as well as if you have any suggestions for me, you can give those suggestions. I will incorporate that and put that in my YouTube channel that I have created. And my channel is fundamentally for solving all business problems. So if you see online in various YouTube channels, they all talk about the problem statement, solution, and all those. So NLP, they will explain NLP and all those. My channel is fundamentally for understanding how to solve a business problem, which is not there anywhere, right? So I'm basically focusing on that. So please do like and subscribe the channel that I've created, and any feedback on that, as well as any set of questions, let's have a call, maybe Saturday, Sunday, you all decide, and then we will come back. Yeah. Any questions you have? Any questions, concerns, feedbacks? Great. Then signing off, I'm just sending my link again of the video, right? How to join, or how to basically become a data scientist, what all needs to be done. So if you can go through that again, or if you can like that particular video, that will basically be very helpful. Please like and subscribe to my channel so that more number of views and it will reach to more number of people.